Hello, this is a demo of where I'm up to with my peer-to-peer chat application, which is written in C and imaginatively called CSEND. It's got a POSIX version, which should run on modern operating systems. I'm going to show you it running on Ubuntu, and it's also got a classic Mac build that I'm working on to run on Mac OS System 7, 7.53 so far to be precise, with Mac TCP. So let's show you some features first of all with the POSIX version. So I'm in the project directory here. I'm actually going to clean down all the builds I've done. So I'm going to make compile the C version. So we'll just type make, the POSIX version. What that's given us is in the build folder, in the POSIX folder, a binary called CSEND_POSIX, and it takes one argument, which is the name you want to be known as for the peer. So I'll put Matt here. So that's booted the app. You get some information about the app starting up. So we use TCP port 8080 for sending and receiving messages, and we use port 8081 for UDP discovery. So that's where the peers on the same network will kind of shout to each other and register what their address is with each other and maintain their own lists of who they can send messages to. You've got some simple commands, so it's all text-based. So you can do things like /list to list what peers have been discovered. Obviously, as we're only running one instance of the app at the moment, it's got no peers. But you could do send, pick a peer from the list and say your message. And it's going to say invalid peer number because, again, we haven't discovered any. If I do /quit, we'll quit the app. It shuts everything down neatly, closes all the sockets it was using, cleans up after itself, and then exits. It will also do that gracefully as well if you do a Control-C or the app gets a kill signal from the OS. So there you go, I just did a Control-C, and it detects that and cleanly shuts everything down. So I'm going to show you now running 3 instances of the app so we can see the communication going on across the local network. To do that, I use Docker. So it's actually going to be a virtual network with 3 Ubuntu machines, each running the compiled POSIX binary. So we'll start Docker. I've written a script for this. You just pass it start as a parameter. And that goes off, and we'll build the containers. So each container is an instance of Ubuntu with the app compiled. And I'll try to arrange these neatly so you can see them. So it boots straight into the app. So if we do /list, there you go. This peer has got peer 3 and peer 2 registered. So this is peer 1. I'll do /list on this one. This has got peer 1 and peer 3, so this is peer 2. And if I do /list, this has got peer 1 and peer 2 listed, so this is peer 3. So I can do send a message, do /send. We'll send it to peer 1. Hello there. And you can see that message has arrived on peer 1. Let's stay on peer 1 and do send to peer 2. So 2 from the list, going off the IDs, remember, individually kept on each instance. Hello, peer 2, how are you doing? And you can see that message has come to peer 2, nothing's appeared on peer 3. And peer 2, we can do a broadcast message, so /broadcast, hello to everyone, how are you doing? And you can see that message gets sent to 2 active peers, and it's appeared from peer 2 on peer 3 here, and on peer 1 from peer 2 here. If you do /quit on one of the peers, it sends a quit notification to the other peers so they know to remove it from its list. So, and it obviously does all the tidy up and shuts down. So we'll close that window. If I do /list now, on either of these, they've each only got 1 peer registered, which is each other, and you can see a kind of last seen record here. So every 10 seconds, each peer sends out a UDP broadcast message on port 8081 to let the other peers know that it's still active. So you can see there, last seen 10 seconds ago, 3 seconds ago. Now, if we close one of these without sending the quit message, let's do a Control C. So we just killed the app, but what it did do was clean up after itself before it quit, so it terminated gracefully. What you'll see here now on the last peer we have running, if I do /list, the peer 1 was last seen 15 seconds ago, 21 seconds ago, 25, 28, and now it's timed out. So each peer, if it doesn't hear from another one for 30 seconds, it will then remove it from its peer list. So if I do /list now, you can see no active peers found. And that's all going off those UDP broadcasts on port 8081. So we'll quit this peer as well. Close down these terminal windows. The script also supports shutting down the containers. So if you do docker, run the script again, and this time supply stop as the argument, that shuts down all of the containers, tidies up after itself, and yeah, they're no longer running. So the classic Mac version, we can build that on Ubuntu as well. So for the POSIX version, we just used make, and I've got a make file configured which tells the compiler how to compile it. We can use make as well, this time specifying with -f the makefile.classicmac. Yeah, so let's run that. That's compiled the classic Mac version there, and you can see it's put outputs in the build classic Mac. This is using Retro 68, which is awesome. It's on GitHub. It's a GCC based cross compilation environment for 68K and PowerPC Macs. So you can essentially use a modern machine like I am, Dell, running Ubuntu with Visual Studio Code to write C code and compile it for modern day operating systems and old 68K and PowerPC Macs. So your G4s, your G5s, your 603, 604, 68K Macs essentially. Really good. So with that built, I can show you what it's done. If we go to the build folder, oops, so build, classic Mac, and we just look in there. It's made 3 outputs, a disk image with the app on. I can't quite remember what that one is, but the one we're interested in is CSEND-mac.bin, and that's a compressed binary Mac file essentially that we can transfer to a real Mac, uncompress, and run the application on System 7, which is where we will switch to now with a different camera view. Okay, so this is where it will get funky. This is a Macintosh Performer 6200. It's had some upgrades. It's got 48 meg of RAM. I'm a power user after all. It's got an SSD put in there. It's got wireless internet, sort of, and it boots into macOS 7.5.3 with Mac TCP installed. So we'll give this a second to warm up. Well, a few seconds, I suppose. Let's zoom you in. So here we are, booted into System 7.5.3. I'll just show you that. So about this Mac, yeah, System 7.5.3. 40 meg of RAM, not 48. More than enough for what we want to do. It's booted up an FTP server called Rumpus. This is the folder it's showing here, and we're going to copy from the Ubuntu machine the binary over. So let's switch to the Ubuntu view for a second. So let's just make sure we've built the app. Yes, we have, so there's nothing to do there. We'll open this folder. So in the build folder, Classic Mac, there's the binary file. Let's switch to FileZilla. Just refresh this so it's definitely connected. Okay, there we go. So this is our empty folder on the Mac, and we shall copy the binary file onto the Mac. Give that a moment. It's going to appear here any minute now. Yes. There's the binary file. We're going to use bin unpack, essentially just to uncompress that file to the desktop. We'll save it. There it is. So that's our compiled Mac binary. Now I'm not going to launch that just yet. What I'm going to do is hide the other apps, tidy this up a bit, just put it in the middle of the screen. We will now launch, back on the Ubuntu side, the POSIX build. So again, in the build folder, POSIX, CSEND, and we'll call this Ubuntu. We've started the app over here. And now, on the Mac version, we will launch it. Let's do a view of both if we can. Okay, so we launched the Mac version. Let's move the window over here so you can see. And there you go, boom. What you can see now is new peer discovered via discovery type message, Mac user at that IP address there. And it's because the classic Mac version is coded enough that it will do the UDP broadcast every 10 seconds across the local network for other instances of the app to pick up. There's some other bits I've coded up here. So for example, you've got a checkbox of whether to do a broadcast message or not. That's just registering that you ticked it or unticked it. There's a send button. It just beeps and tells you that the input field is empty at the moment. There's an invisible text box here that I need to code up to display, allow you to type and send the message. And this box, well, this space here, is where there's another invisible control at the moment, which is where we're going to show the peer list when I've coded that up. So the only other thing I've coded up is the quit button here. So if you close this window, the app will quit. It's got the same code to gracefully shut down. Well, not exactly the same, but it does close all the ports it was using and shut down gracefully. And what you'll see now here is if we do list. Yep, so it was last seen 27 seconds ago. If we do list now, the Mac version, because it's quit, hasn't sent that UDP broadcast message out, and now it's been removed from the peer list on the POSIX version running on Ubuntu. Alright, so back on the Ubuntu dev machine in Visual Studio Code, just to look at some of that. If you're still with me, well done. There's three main areas for the C code. There's a shared folder, which has got standard vanilla C code, if you like, that's used across the POSIX version and the classic Mac version of the application. So what's worth a look in there is probably the common defs file, common definitions. This has got things like the buffer size for a message, so we're going with a meg. The length of an IP address as a string, what ports to use for TCP communication and UDP communication, information about how many peers we should store, the discovery interval, in seconds. So that UDP broadcast, it gets sent every 10 seconds. That's where the time limit for that's set. The peer timeout, so it's set to 30. We've got a struct here in C. This is basically a way of kind of creating an object that contains information about a peer, and we maintain a list of these peer structs, if you like. So you can essentially traverse a list of peers, and each one will have an IP address. We'll know the username. We'll know when it was last seen, and we'll know whether it's active or not in the list. What else is useful to see? Protocol.h and .c. This is the messaging format for the communication. So what's useful here is the message types we support. So there's a message discovery type and the discovery response type. So the first case here, that's sent every 10 seconds via UDP on port 8081. And when you send one of those across the network, it hits all the peers on that port, and they will read it, pass that response, and respond with a discovery response message. And that's how the peer-to-peer registration side of it, the automatic finding of each other on the network, works. You shout from one peer across the network, that gets picked up by one or more other peers, and they send a message back, a shout back over UDP, and either end registers and adds that information to their list of peers. There's a message text type, so that's the message type that's used for sending just messages, as you saw. And then there's a quit message, special type of message which lets a peer know that another peer is leaving the network, essentially, so that they can remove that peer from their list. There's some useful functions. So function format message. So what that does is takes information to format the message into the format, essentially, to send across the network so that they're all standardized. And there's a function to pass incoming messages. And when I'm saying about the format of messages, if we go to protocol.c, I've got some examples here. So it's a dead simple message format. You basically got the type, the sender, the IP, and the content separated by a pipe symbol. So there's no encryption. This is not Signal. There's nothing very deep happening with the sending the messages across the network. So there's a bit of an example here for how you'd send a message. You'd have the type set to text. You'd have the username, an @ symbol, the IP, a pipe, and then the message text afterwards. So hello Bob in this case. And a discovery message is pretty much the same, except the type is now discovery. You've got the username, the IP, the pipe symbol, but no message. There is no text message sent with a discovery. It's purely cut down to the information needed for another peer to register you on the network. What else? There's some similar patterns. Try and make things easy to read between the POSIX and the classic Mac version. So an example of that is in the discovery code. So if we look at the header file for the POSIX version first, what you'll see is it's written primarily using sockets on which is a C library to work with networking. It's got a function to initialize the discovery socket, so the UDP communication. It's got a function that's a thread, so that it will run in a loop, essentially, and send that message out every 10 seconds and be able to listen for incoming messages, whilst also doing other things like letting you use the user interface to send messages, that sort of stuff. And it's got a function to do that broadcast sending of the message, so that's what gets called every 10 seconds. And it's got a function to handle incoming broadcast messages. So that's where it'll receive a message of a broadcast type from another peer and register it in its list. And if you look at the classic Mac version of the discovery header, it's written for Mac TCP using that library. So there's slight differences because it's a different stack we're working with, but the kind of structure is very similar. There's a function to initialize the UDP port and socket. There's a function to send that discovery broadcast. There's a function here to check whether we should send the broadcast, and that's because you can't really do threads on classic Mac programming. It's like an event-driven model. It's different to how you do it in the POSIX version. So there's a function essentially to check, has 10 seconds passed, should we go and send, call this function and send the broadcast message. And there's a function to clean up the UDP endpoint resources, basically, help shut down those ports as the application quits. So there's a similar pattern between the two, but they're quite different in the libraries they use to handle communication, basically. And I think that's it for now. The rest of it's there. Everything is commented. There's no excuse these days with the power of LLMs not to have beautifully commented code. So everything has got full dot block style comments on the code. Makes it much easier to read and think and refactor.